Hey guys, it's Gary back in Indiana and back with another laser install, this time with a Sidewinder tube laser at KASCO Manufacturing. And you guys may remember a few months back, I was here for a big press brake install, 10-foot, 220 ton. You might have saw it in the background. You can kind of see it right here. They've been using it for a few months and just absolutely loving it. And then now we're back adding a tube laser to help them out with getting a lot of tubes that they do processed for the machines that they make. These machines start at 89,000 delivered. They have a capacity of 24-foot tubes, 9-inch diameter, square or round, and they are 41 feet overall with the 11-foot outfeed table. So you may remember when I was here back earlier this year, putting in the press brake and doing training on that we did a complete tour of their facility and showed a lot of their finished products of the ag implements that they make. Lots of attachments. They OEM for some bigger companies. I'm not going to say the names, but here's a look at, kind of what they make. And you can see there's a lot of sheet metal, a lot of tubing involved.
Yeah, I mean, just depends on what attachments you get. But they go all the way up to 30,000. I would say the cheapest one to get your foot in the door is probably 6,800. But they're all different versions. There's Haymaster, Plotter's Choice, Seed and Pack, Value Drill. The Varimax that's back there, you can actually change how aggressive your discs are in the middle. So there's a handle and it changes.
So this worked out to be a very efficient trip. The week before this, Chris and I were in Fort Wayne, Indiana, and Chris broke away for one day while I continued on with training in Fort Wayne to drop down here to Shelbyville, Indiana, to KASCO, to go ahead and do the physical setup, get the power source, laser source mounted, head mounted, and then kind of give them a little bit of guidance on, wiring the electrical and all that while I finished out the other week in Fort Wayne and then made the drive down here the next week. But these guys did a great job. Everything was, about 90% prepared, which is all you can expect. But the more prep that's done in advance makes it more efficient when we get there to actually do the install and the training, and we're focused on training and learning and not, machine setup. So I've tried to do a better job of communicating that to customers, and Jared here at KASCO and his whole crew there, his mom Danette, his brother Jonathan, just awesome people to work with. So here's a look at a very common product that they use in, I think maybe more than one of their machines that they sell. And this is like a shaft collar. I believe it was 1.25 OD. I don't remember the wall thickness, maybe like 0.150, something like that. Just a simple part with a through hole all the way through for a locking pin. So previously they were gang cutting all of them on a bandsaw. And then once they get them gang cut, they do all the drilling and tapping and all that as a secondary process with a series of 4 or 5 drills that they have set up here. And you can see this particular one, this is Mikey running the drill here and a bucket of parts. And we're hoping that the tube laser will be able to replace all these small parts that they make.
The last time I have to do these.
Yep, last batch. Got it.
Yeah, there we go. Oh, so I had it in front of these.
Normally you do want it there, because you have all that gripping area.
For the square stuff.
But that little tube, it'll be fine doing it that way.
That's the smallest that we do.
So this is whippy, right? It's moving up and down.
Yep, so I should probably adjust these.
Yep, so we'll give that a little support. Give this one some. There we go. And then rotate your W axis, fast rotate. Looks good. So we literally did some very basic training to kind of get going and immediately jumped into cutting some production parts for them. So we got this full stick loaded up and we're going to whittle the whole thing down into a bucket of parts. And we didn't time it, but obviously the speed at which you can do this compared to bandsaw cutting and drilling holes is a significant improvement. Going from a plasma table to a sheet laser is, not a hard transition. A lot of guys can make it. It's definitely more complicated, but doable. Going to a tube laser brings in many more elements, and one of them is the ability to do 3D modeling and 3D drawing, like in SolidWorks or Fusion 360 or Inventor. Many different products available to do that with. And I was pretty excited to be able to have Kevin from Mechanical Advantage join alongside, and we did a great video series, or working on a great video series to be able to include and package in those machines. And you'll see kind of Kevin at work here doing some training on with
2.5 by 2.5.
Grab mine. And I'm just going to draw my center point rectangle for that I like to use. Yeah. We can talk about your offset of the order. What was it?
2.5 by 2.5.
So I don't know if you've used constraints. I have to do this stuff. I always just like to do it the direction I want to go.
Yep.
And then for the distance, I'm going to do an all.
Do all.
And then I'll hit OK, and then we got our holes.
Yep.
Now again, because of the way I did this, I can just mirror those features of that extrusion across that mirror plane. It might not punch
My
all the way
holes may
through.
not go all the way through, so that's why.
Yep.
Because normally what I would do is I just, like I said, I would just drag them down, leave them grouped, so to speak, because that's how in my world it would be.
Yep.
But this makes a lot more sense because if we just change the thickness, like.
Something's wrong. I'm not going to lie, there's a lot going on here with these tube machines between Fusion 360, the middle components of setting up the tool path, and then you add in and overlay the element of dialing in the laser itself and fine-tuning how the cut quality is. It's a pretty steep learning curve, and that's why I was pretty happy to be able to say at least the 3D modeling part of it, we got covered with Kevin's videos. So every tube laser that I sell will include a very detailed library of videos on how to draw all the various types of tube components, square, round, angle iron, all the structural components, and not just draw them, but draw them in a way where they're fully constrained and that you can be productive with the way you need to edit the drawing in the future, make the tube longer, change where the holes are, instead of having to do like I do, redraw the whole tube again. He's got a way of showing this where you can simply make adjustments, but you have to build the tube in the first place with fully constrained, and that's the part a lot of people don't take the time to learn, and he shows it in detail. So that'll be included. And then in addition to that, we're going to include 2 free hours of one-on-one time with Kevin via remote sessions. And, so if you get stuck on a drawing problem, he'll be there to support you with that. Of course, I will do the on-site training just like I always have been, or you can come to me and get training for the actual tube machine itself. But the actual drawing part of it is something I've never really offered, and so I'm pretty excited to be able to do that. So this was the first part that was completely we took a measurement off of their example, and then here you see the two original bandsaw cut compared to our laser cut part.
If anything, nope, hold on. Yeah.
Was this one hand drilled?
Yeah.
Okay.
Yep.
So the holes on the hand drill
No.
one may not be
Perfect. Yeah, he'll tell you. He'll be the first to tell you.
Now you give me your intro, and you're good. Okay, and then you can continue on.
So then I would just go
Measure the thickness of. And for this part, I wouldn't even worry about the dimensions quite. Just kind of roughly draw the rest of your angle in, and we'll come to dimensions after.
It's doing a thing.
Definitely didn't like that. I kind of covered this in the video with Doug, where sometimes I can kind of come across, you know, a little on the harsh side when I'm training and working with someone. But again, if you can't take me giving you a little coaching and guidance, man, this machine's going to kick your ass every day of the week. So it's going to be way harder on you than I am. So you might as well kind of get used to getting your feelings hurt a little bit. I don't mean anything by it. I'm just kind of, you know, trying to get people to recognize that you got to be able to react quickly and make changes and recognize what's going on. There's a lot to learn. I mean, there's no question about it. It's just a lot going on, a lot to learn for sure.
I'm not quite to where you are, where I can just start moving. You know, thickness is this and thickness is that. But eventually, I want to get to that point because if I can.
So right here, we're cutting this tube with compressed air. I believe this is 8th wall or 3/16 wall. Can't remember. I think it's 3x3 by 3/16. And you see it's doing a really nice job, and anything you can cut with compressed air is definitely an advantage. At the very tail of this video, I'm going to overlay a clip that Jared sent me after the fact that I asked him to make for me. We ran into an issue with the shaft collar trying to cut that with air, because air cutting on plate or tube beyond a certain thickness, let's say beyond 14 gauge, starts to produce a burr. And so that shaft collar had a pretty tight slip fit onto the shaft that it goes on, and that little burr on the inside was going to make it not usable. So we ended up cutting with oxygen, which is a little bit more of a messier process. It's hotter, a little bit more expensive to cut with oxygen, but in the end it made it so that the parts could be taken right off the laser and go right into powder coating or, you know, cleanup or whatever. And no matter what we did to the one cut by air, even with a little deburring, it still wouldn't fit right. So these tubes here don't need a slip fit, or if the slip fit being used is a little more tolerant, you know, no problem. We can cut it with air. You can hear the high pressure there. So here's a video Jared sent me of cutting those shaft collars on oxygen, and I showed it in more detail earlier in the video, but here you can see the fit up. This is one, and you can kind of see the result that you get cutting with oxygen on this kind of tube. It's no burr on the inside, and you can see it fits right on there. And then here's the one cut with air, and even though we deburred this one a little bit, you can kind of see where a grinder had been ran up in the middle of it. It still doesn't fit on there. So it'd be great if this could be cut with air, but it sure is nice to be able to take a part off the machine and put it right into the next step of the production. Big shout out to Chris for always helping me, and of course to all the crew at KASCO, starting with Grandpa, Jared, Jonathan, and of course, Danette, aka Mom, the matriarch of the whole operation. Thanks, guys.